recording again. Okay, so let's look for this example that they show us how to combine like terms and when we cannot do because they're not like. Check this one, 3x plus x minus 2. That we already saw, right? 3 plus 1 minus 2, 2. But these are not like terms because they have different variables, x, y, and z. So we cannot combine them, right? And I'm trying to show you the comment there over here. Now, check the other example. If we have them with exponents, the exponents must be the same, right? So like terms are the ones that have the same variables with the same powers. So here we have y squared and y squared. That's why we can combine their coefficients. This one has a coefficient of 1. Do you remember how the coefficients have been hidden, right? So if you don't see anything in front of the y, it means that we have a 1 there. Let me put the 1 here. So it's like having the 1 times y, right? 1 times x. So 1 plus 6 will be 7, right? And now when we combine, we follow the signs. What are the signs, right? 3 plus 1 minus 2, right? We follow the signs. Okay, now over here they had different powers, so we were not able to combine, and usually we just leave them as is. And these terms are called unlike terms, right? Okay, now the next step, last one. The last one, and I think I need to clear. Yeah, go ahead, you have a question. No? Okay, yeah. Okay, so check this one out. This is when we need it, when we have crazy expressions and we need to rewrite them. Now, when we have more than 2 terms to combine and different pairs, right? We like to use underlining. So for example, check this out. This is y and this is y. So these are 2 like terms. I'm going to combine them. Positive 6 minus 4 will be positive 2. So this is the result of the combination. Right? And then check this one out. This one and this one. Look at the variables, xy squared, xy squared. So same variables to the same powers. So 3 plus 2 will be 5x squared, 5xy squared, sorry. So this is the result over here. And this one, this is the one that didn't have a body, right? So it couldn't be combined with anything. So we'll just copy it over at the end. The word of caution is don't lose them, right? Because sometimes we lose them. Okay, so this is about like terms, right? This is all the information about like terms, and this is all you need to know. But things can get really complicated, and we'll see it in the example later on. If the web work, I'll show it to you that, you know, sometimes you're like, what? You know, what am I supposed to do with it? It's when you usually need to apply several techniques. Use the distributive property, combine like terms, do more work, right? So let me know if you have any questions so far. Time is good. Timing is good so far. Everybody's good? Okay. So let's scroll down. Here they are combining like terms, but they do it in a word problem. So let's play with it. And if you have any questions, don't hesitate to ask. I'll read it, but with the stylet in my, in my head, because I want to underline some things. More wants 2 15-minute breaks for a 4-hour road trip. How long should each driving stretch be if each is the same? So what I think is those 15 minutes are incorporated into the 4 hours. And, we could see the confirmation later on from their solution. But here is what they're talking about. So we have the 4 hours long trip, and we want more ones to have 15 minutes break. So this is a break, 15 minutes, and this is a break, 15 minutes. Okay, and this is travel, 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 right? Same travel. And it's all, since it's minutes, we need to do in minutes, 240 minutes, right? Okay, now, do you see what equation do they have, right? So compare what I have here and compare what they have here. What is this x, right? I'm thinking about like, what is this x that they have? Isn't it exactly those stretches, right? So see, stretch B if each is the same. So these wiggles that I have over here, these are the stretches and they must be the same. That's why they use the variable x for it, because it's the same. That's how they got the summation. X plus 15 plus X plus 15 plus X, right? So these are stretches, is equal to 240, right? So they converted the word problem into an equation. And in this equation, we need to combine like terms, right? But once again, so this axis over here are my wiggles, right? In this picture, 2 breaks, right? That's what we had. And then the stretches are the same. Then we solve it. We have 3 axes, so we'll combine them into 3. We have 2 15s. 15 plus 15 is 30, right? And then we'll solve them, right? I just want to wait a little bit to make sure that nobody has questions, and then I'll scroll down. So let me know if you have any questions. All right, it's good. Okay, so because I'll have to raise them, they will be obstructing the text. So check this out. Here they are solving it, right? And the first thing they do is they move this 30 to the other side, right? Or they get rid of it, or they do minus 30, right? So first the constant goes out, and then they will deal with the coefficient. So once again, we didn't solve the equations yet. We will be doing it in the next class, but it's already like all the examples we are seeing is kind of where it will be used, right? So check this out. They had the 30, they subtracted 30, right, on both sides. And what happened is that these two got canceled, right? 30 minus 30 is 0. We have 3x, 210 on the other side. And then they divide the 3x by 3, because when we do the division, they will cancel, they get 1, right? 1x. And then the right side, it's 210 divided by 3 gives us 70 minutes, right? So that stretch, that x, which I show with you on the picture is the wiggle, right? With the breaks, wiggle, break, wiggle to 40, right? So there were 70 minutes, 70, 70, 70, and those were 15 and 15, right? So that's, you know, what the answer is. Each driving stretch should be 70 minutes long. Any questions?
I don't have a question. I was just gonna make a statement and just see if I'm on track. Like so, like the you minusing the 30 on both sides. The reasoning for doing that is just to it's like simplifying it so you have less to deal with.
Yeah.
Right.
Yeah, exactly. Yeah. So the goal when we solve equations is to isolate x. So the reason of why we're subtracting 30 is to make it simpler on the left side where the x is. Yes, exactly. You're right. Okay, let me check the chat messages. Why there were 3 x's? Good questions. So how did we know? Because they said 2 breaks. Where is my mouse? Here. Check this out. They said more wants 2 15 minutes break for a 4-hour road trip, right? So 2 breaks means that you drive, then the first break, then you drive, then the second break, and then you drive. That's why we have those 3 squiggles. Yeah, because 2 breaks. You don't have like the break in the beginning, right? And you don't have at the end. You usually have like in between. Yes, that's why 3 axes. Let me check the chat messages. Goes to just 2 stretches. Yeah, so I answered 2 questions, right? Okay. Oh, okay.
Say that one more time. You said
about stretches, right?
Yeah, you said there's 3 stretches.
3 stretches, exactly.
So I'm reading and I'm trying to see what you said. There's 2 15-minute breaks and then is a stretch in between each break.
Which is the same. Yes, stretch means that it's a driving stretch. At least they call it driving.
Or how long you're driving for?
240 minutes. You see, 4 hours. That's what you have to realize in the beginning. These 15 minutes, are they standing aside from the 4-hour drive or they included? And you know, usually you would ask this question like, what do you mean? Do 15 minutes included in the 4 hours or not? Here they did include it, and it's seen from this equation. That's why I said, you know what, we will include those breaks in the 4-hour trip.
And that's what makes it 3 stretches.
Yeah.
That's how you came up with the number
You
3.
usually have the breaks in between the drivings, right? So you
Yeah.
drive and then you take a break. And then you drive and then you take a break. And then you drive and then you take a break. But they're saying that we have only 2 15 minutes breaks. So that's how you know. So when you do this picture, right, you know that you drive and then you have a break, right? And then you drive and then you have a break. And then you drive and you cannot have a break because they have only 2, right? That's how I knew that there are 3 wiggles, squiggles, X's.
I got it.
Okay. Let's go to the next one. I think we have only few left, but there is still few left. Okay, like terms, right? Just for the practice, right? So, what do you think about the first pair? Are they like terms or they are not?
Like terms.
Like terms, and I'll open the chat window so that I could see it. Yeah, they are like terms. Yeah, I agree, because it's X and it's X, right? And it doesn't matter that the coefficients are different. Now, check these ones out, X squared and 3X. Are they like terms or not?
They're not like
No,
terms.
they are not.
No, yeah. Okay, magnificent. How about the number 3?
Yes.
Yes. Yes.
Because both have XY, right?
Mhm.
Now, how about this, number 4?
No.
No. Okay. You see, they say 2 doesn't contain M. Okay. Now, how about 5?
No.
Yes.
No.
No.
Yeah.
Sorry. Oh, I didn't see that number.
Mm-hmm.
No.
No, right. So
No.
because of the power of X, right? Because it's here 3 and here 2. Y is
No.
okay-ish, right? But X is not like terms. Okay. How about the last one?
No.
Yes. Yes.
Yes. Yeah. You cannot say no because XY.
It's the same things. It's just reversed.
Exactly. Yeah. XY can be rewritten as the product of Y and X, right? So yeah, we cannot say that it's not like terms. It's like terms. Yes. Okay. Excellent. Wonderful. So everybody's on the same page with me. Okay. Now,
Wait, can you go back up? I just wanted to see the reasoning they provided for that last questionnaire.
The order of variables doesn't matter as long as each term contains X and Y raised to the same power. Yeah.
All right, thanks.
It's, what is it? It's called commutative law, right? Of multiplication and addition. So they can commute. So now here we are combining like terms and they want us to check which one is the correct answer, right? So for each of the combining expressions, we have 2 possible answers. Which one is the correct one? So how about number 1?
No.
No, you don't say no. Say first one or the second one. So it's either this answer or this one. It must be one of them.
The first one is correct.
The first
Second.
one or the second?
The first one.
The first
Oh, the second. Yeah, the second.
Yes. Yeah, the second one is correct.
It's the second one.
Second one is correct.
It's
Excellent.
the second one.
Second
Because
one.
there's three X's and then that one X will add to make it a 6X and then you leave the 9, the
Yeah.
plus.
Yeah, I agree. We are choosing the second one. Yes. No, this one is weird, I'll tell you. But I mean, definitely if you find it as a number, it doesn't look like it's 6 times 5, right? Because it's like 1, 2, 3, 4 5s. Yeah, but this one looks good, right? Yeah, 4 5s. Yeah, this one I will not be like, bothering you with. Do number 3 for me, please. What do you think the answer is?
The second one.
Second one.
Second.
Second. Second, right?
Second one, you can't add it because it has to the second power.
Yeah, because the power is different. Yes. So 1, 2, 3, 4 x's. That's the answer. Yes. Okay. Number 4.
The first one.
First one. Yeah, because you see
Yes.
x and x squared and x squared, so they go along, right?
Mm-hmm.
And the last one, we are not combining, right? Because it's x cubed and it's x squared, we cannot do anything. Okay, so no combining. Excellent, and we have one last problem to do. I'll do only one of them. You can practice for the rest of them at home, but usually the challenge problems are a little bit more challenging, but you'll see that they're not really challenging. What they do here is they usually give you 2 or 3 examples, different ones, and you are asked to do the work there. So for example, here they're asking me to simplify this expression. Now, 6x and 2x, and you see this x over here, so you'll know which coefficient to put there. 6 plus 2 will be equal to 8, so I'll put it here, right? And 1 plus 4 will be 5, so I'll put it here, right? And then I do the check. So if it's good, then it's okay, and it proceeds to the next one. If it's not, then shows me the solution anyway, so I can re-enter the correct one. I'm not even sure if you need to re-enter the answer. Maybe it will already count it in, but you'll experiment for yourselves and you will see. Now, what I want to show you is a couple of problems from the homework assignment. So we have like 10 minutes left. I have plenty of time, but I wanted to show you the 2 last ones because they're more like the most challenging of all the problems. The other ones you'll be able to do with now, I don't think that you'll have any issues with them, but this one, for example, is a word problem, right? So let me read it to you first, but let me wait a moment just to make sure that everybody can see my screen. Okay. So we have a rectangle of length 13x plus 7 and width 13x minus 2. I'll draw it. What they're asking us to do is to find the perimeter, right? So here is our rectangle. The length is 13x plus 7, so it means the 2 sides are at that length, plus 7. And then the width is 13x minus 2. It means that 2 sides are having that length, right? And then if you can recall, the perimeter is when we add up all the sides. So we do this, and plus that, right? So that will be the perimeter for our rectangle. And this is a multiple choice question, but check this out. You have unlimited attempts remaining, right? So I'm not limiting your attempts, but try not to guess, right? Try to work them out here because it's all about the tests then, right? And the quizzes so that you would know how to do things, right? And guessing doesn't help us. So this is one of the questions that I wanted to discuss. And the other one is the very next, like it's the challenging problem. If you don't have any questions, I'll erase this and I'll show the last problem for us. Okay, so it has to do with the distributive property, but it's a weird looking expression, right? So check this out. I'll have to distribute this sign here and this sign here. So 2 signs, this one and this one, and only then I will be combining. And of course I will start with the inner ones, right? Because they are easier. And now just if you can recall what this negative means, it means that I have a -1 here, right? So I have to multiply -1 times this, -1 times that, right? So I'll open these ones first, and then I'll open this one.
Hello?
Yeah, go ahead.
Yes, what you were just saying, all right, you put the 1 right there, but like it was just a minus sign. So whenever you just see a minus sign outside of parentheses, that means that there's just a there's automatically a 1 there.
Yeah, because it's a product, right? And it's absolutely okay if you don't reveal the one, but you distribute the sign, right? So you could do it the same thing without the negative one, right? Just with the negative. Just as long as you understand that it's like a product there, right? Like negative 1 times this, we could rewrite it. If you work with the signs correctly without the negative 1, go ahead and do it. I usually do
So product, well, when you say product, what do you mean by that again? Was
because
that
it's a product here, right? It's a times here. It's not times by this, right? It's like this negative has to be distributed. You could do it like this also, right? But what it means is that this negative has to be distributed for all the terms, right? So I will have to rewrite it as negative 3xy cubed minus 8x squared y. So this negative is not the sign of the first term, right? This negative should be attached to every single term inside the parentheses. That's why they say very often that treat it as negative 1 times. If you forget to do this, treat it as negative 1 times. Just, for that.
Got it.
Got it? Okay, so that's what we will do here. So we will rewrite it as 7x squared y minus 3xy cubed. I'm not opening it yet. Minus, and then minus 3x squared y minus 5xy cubed. And then here, minus, like what I have here, 3xy cubed minus 8x squared y, right? And then the second step will be to introduce this minus in. Let me check the chat messages while you're just looking at it. Eventually, the negative on the first parenthesis will need to be distributed also. Exactly, that's what I'm going to do now. But you know what's nice about it is that like everything will cancel to plus, right? Yeah, like check this one out. This one times this one, right? Negative times negative is positive. Negative times negative is positive. Negative times negative is positive. Negative times negative is positive, right? So everything will become positive. So we'll have 7x squared y minus 3xy cubed plus, right? Because it's negative times negative, plus 3x squared y, and then this distribution, right? Negative and negative, plus 5xy cubed. And then the next one, right? Negative and negative, plus 3xy cubed. And then finally the last one, right? Plus 8x squared y. And then we will be combining like terms, right? So it might look scary, but just be very tedious. Do the distribution of the sign, because we saw in the distributive property only the number, right? But the sign also could be distributed like, we did here. And then you'll combine, and then you'll pick one of the answers here.
Question, why does the negative cancel out the other negative?
Because negative times negative is positive, right? So that's where this negative 1 comes from. It's like you're imagining that you multiply the negative 1 here by negative 3x squared y. So this is how you're imagining it. You do negative 1 times negative 3x squared y, right? Negative by negative will be positive.
I'm not to be difficult or anything. Like I'm just like I remember like in back in school, like when they was showing us the scale, like because when you added negatives, a negative plus a negative just increases the negative. So why when both with multiplication is it different? I'm just curious. Hello?
Good question. Yeah, it's a good question of why are we changing why did they come up to the idea that we should change the sign, right? Cannot give you a very nice example of why it should be done. It's just the rules of these numbers, right? So when we multiply a negative number by a negative number, we get the positive one, right? Because it's the different idea. Usually the multiplication is about area, right? It's like you have a figure, maybe it's 3 length here, 4 length here. So when you multiply, you get the entire thing. But when you add, it's not the area, right? It's like you're adding like things. So if you have the -2 plus -3, it's like you're adding the things that are like, right? It's like you owe it $2 and you owe it $3. Now you owe $5, right? So it's in this sense. But multiplication is not about this, right? And you cannot say that you owe it $2 and you borrow 3 more and now you multiply. Like, it's weird. That's not the association here, right? And I just cannot give you a good, nice association with the negative numbers when we are multiplying. So with addition, it's easy to do, but with multiplication, the only connection we have, like, demonstration, right? Visualization is the area. So it's just the rule. Okay. Okay, now let's stop here. I'll stop the recording and I'll show you what our next assignment is. So what do we need to do by the next class and what do we need to do by next week? Faster method. For me, it's very fast to distribute just the negative sign. Don't think about the -1 multiplication. But I did find that for some people, -1 multiplication is better. For me, I just, negative, negative is positive, negative, negative is positive, but it's about multiplication. So I still have to keep it in mind. I would recommend, again, you could try to open this parenthesis first instead of these ones. Just be careful, with the signs there, because this negative will cancel this negative and they will be left as this. But sometimes we mess up with the signs there. That's why they usually recommend to start from the inner parentheses and then go to the outer ones. So something like that. Okay, so I'll